Tessa. This is our boat. We made it out of styrofoam, so all of the red part would be styrofoam and it has duct tape over it. And this is our engine, and it's made out of like a aluminum can, and we folded it up, and basically you put the candles underneath it so it heats it up, and we have straws coming out. The buoyancy force is equal to the force of the earth, which means that the sum of the forces is equal to 0. You can see over here that the boat is displacing some water, but that is balanced out in the masses of the boat and the nails. So the volume displaces up with the buoyancy force over here, and the force of the mass of the boat and the nails is down below over here. So these two equations equal each other. My engine's over here, and we have the straws over here, and basically when you're getting your engine to work, you put water in the straws, so then there's going to be water in your engine. And the engine is airtight, so there's no water that's going to be able to get into it. And when you light the candles are very close to, like, kind of almost touching the engine, so it's heating it up. And that's where your heat comes from. Delta U is internal energy, Q is heat, and W is work. Delta U is increasing at this point. The change in internal energy is increasing because the candles, delta U is proportional to temperature. And the candles are obviously making the engine hotter. And at this point, like at the first point, when we're getting it to move, the engine, like step 1 is heating up. So delta U is gonna increase. Work is 0 because your volume isn't changing at this point, and that means that Q would increase as well. The work in this case from B to C as it's expanding is negative because the change in volume, it basically expands it outwards, which means that the steam is colliding and pushing outwards as the air from outside of the system is pushing on the engine and wanting to make it go in. So the direction that the engine is moving in or expanding is opposite to the way that gravity wants to push the engine in. So from A to B, like I said before, delta U is positive, heat is positive, work is negative because it's expanding. But from A to C, we see something else happen where it contracts. And that's what I was explaining before in the vacuum part. As it expands enough and pushes the steam out, it's going to contract back in as it sucks the water in like a vacuum. So A to C, we see a change in delta U. It's negative now because heat is negative because the cold water is coming in as the hot steam is pushing out. And work is positive in this case because opposite to when it expands, it wants to now go the opposite way, which is the same way that gravity is pushing on the engine. PV equals nRT is incorporated in this system as well. And from B to C, as it expands, that means the volume's increasing as well. And the pressure was increasing from A to B. And as that's done, the temperature increases as well, which is another explanation for why from B to C, Q is staying positive, because the temperature is increasing as the volume increases due to PV equals nRT. From point C to A, it contracts, like I said before, due to the vacuum kind of system working on here where the steam is pushed out and the cold water is sucked back in, and that's where it contracts over here. So the whole system altogether is explained in a pressure versus volume graph, and it really helps to get the concepts like all put together. I wanted to explain how AV equals A1 times V1 equals A2 times V2, how that equation ties into this whole process. We have, in the engine system, we have two areas pretty much. We have the areas of the straw, and we have the area of the engine itself. So I said that the engine itself is A1, and then the straws, which are equal areas, are A2. So the engine is obviously a bigger area than the straws, so we have A1 being very big and A2 being smaller. Because that happens and the equations are equal to each other, they have to balance out in some way, which comes to the velocity. When A1 is big, V1 is small. When A2 is small, which is the straws, V2 is very big. So that explains in the pressure versus volume graph why as B to C is expanding, the area is getting bigger of this part, the velocity is going to be smaller. But when it contracts, when the straws are pushing out the steam and pulling in the more water, as it contracts, it goes a lot faster. So that's actually what's going to be pushing the boat. That's where the velocity comes from. That's where we're pushing all of our nails in our boat as fast as we can. Thank you for taking the time to watch my video on how a pop-up boat actually works. Thank you.
No, thank you.